If you're preparing for Google's machine learning certification, then in this video, I'm going to cover everything that you need to know and understand to prepare for this certification, including what to expect and how to prepare for this certification. So very quickly, let's look at what you will be getting in this video. We'll beginning with exam overview, covering detailed breakdown of exam structure, key domain topics and their exam weightage. We'll also look at insights from who or what's to expect and how to approach this exam strategically. We'll also give you the study roadmap on what topics to focus and how to learn them effectively. You'll also look at the hands-on lab and the practice test and the key resources to make sure that you have the real-time word examples so that you can clear the interview. We'll also give you certification roadmap, preparation, step-by-step guidance, and things like data engineering, model development, deployment, MLOps, and tips to balance both theoretical knowledge as well as the hands-on practical knowledge. This video will also cover the frequently asked questions, so make sure you watch till the end to make sure and get maximum out of this. Now, if you want to learn quickly, you can play it in 1.5x, but make sure you watch till and thoroughly as well. That will also help you. This certification is the most in-demand certification if you're preparing for AI, machine learning, generative AI kind of a career as well. And below this video, you'll also have all the links that will help you to understand. And if you need any help, leave a comment below this section. And just to let you know, if you're new to this channel, my name is Atul. I have close to 2.5 decades of experience in IT and last probably more than a decade now in cloud, multi-cloud, and last 3-4 years has been machine learning, but primarily focus on helping our clients to get certified, help them in job, and implement AI machine learning as well. So whatever you're going to learn is coming from real experience, and the methods that are being given in this video are tried and tested and being helped by thousands of our students, and you'll get benefited. If you need any help, leave this, and with that, let's look at this video now.
Hi everyone and welcome to today's video. If you are passionate about machine learning and cloud computing and you're looking to elevate your career, you're in the right place. In this video, we're going to talk about everything you need to know to successfully pass the Google Cloud Professional Machine Learning Engineer certification. We'll cover what you need to learn and how you could learn it to maximize the chances of success. We'll cover the whole exam structure, including the key domains and their weightage. We'll also address the common questions that you might have about the whole certification process, and at the end, we'll provide you useful resources, including the practice tests and the hands-on lab. So we'll begin with understanding the whole exam structure. We'll discuss the differences between AI, ML, and Gen AI. We'll show you how to cover the whole exam section by section, as you can see over here. And then after that, we'll also provide you practice tests, which you could take after you're done learning with most of the sections. Then we'll also discuss the frequently asked questions, both the non-technical ones as well as the technical ones right here. We'll discuss all of them in detail. And after we're done with that, we'll give you a model-wise agenda of all of the hands-on lab that we'll be covering. We'll also refer to the blog that we have posted, which shows all of the hands-on lab that we will be working with for the certification. We'll cover all of the 12 modules step by step. And at the end, we'll give you the related references of the hands-on lab blog and also another blog which talks about the certification in detail. We'll also give you the resources by Google, which will show you how you can book your own certification exam. And finally, we'll also provide you the exam guide, which is given by Google. So let's get started from the beginning. To give you some context, this video is taken from our training program at K21 Academy. So there might be some references to the training. Feel free to skip those if they're not relevant to you. However, rest assured that we'll cover everything you need to know about the certification. Also below this video, there will be links to download the documents I refer to. So you can have all of the resources at your fingertips. So I will show you on how you can find it. In the search bar, you just have to type K21 Academy. .com/sk, which stands for school, /GCP, which is Google Cloud Platform, and then you have to type AI/ML, which stands for Artificial Intelligence and Machine Learning, and then you'll have to type self. So if you have the job-oriented program that we have, these are the things that you will get. So in this page, we'll talk about the certification. So the video you're watching right now will be posted right here, and you can refer to the documentation by clicking in this link. That's where you can find the whole documentation, so you could look at it when you want to know how the whole certification works and all of the sections in detail. Once you're done with that, you can head over to the quick links section, in which you will find all of the helpful resources that you have, which includes the Cloud for Beginners course, as well as the Google Cloud for Beginners course, which you could check out. So for Cloud for Beginners, we'll cover how the whole cloud works from start to end and a basic overview of what you need to know before you start doing the course. If you're new to cloud and if you don't know how the cloud works, I highly recommend you to check out this course, as well as how the whole Google Cloud works. We have a course for that as well. If you want to know Python for AI, ML, and data engineering, we have that too. And this is where we'll be covering the question and answer section for the Q&A. After you're done with all of the sections, we have given you practice set questions right here, which you could access by clicking on each of the pages, which we have provided you 3 sets right here. After that, we'll also provide you the live session recordings when it starts. And when you're done with the whole course and you actually want to search for a job, we have curated a section over here in which we will teach you on how you have to update your LinkedIn account, how you have to frame your resumes. And this whole section will just be a step-by-step guide on how you could get a job after learning everything you need to know. So let's get back to the document. If you have any questions or if something isn't clear, please leave a comment below. Feel free to fast forward through any of the parts that you're already familiar with and jump to the sections that interest you the most. So with that, let's get started with everything you need to know about the Google Cloud Professional Machine Learning Engineer certification. So we'll start with the introduction. So you might ask what the Google Cloud Professional Machine Learning certification is about. In simple terms, this certification validates your ability to build, deploy, and manage machine learning models on the Google Cloud Platform, or GCP for short. Machine learning is a subset of artificial intelligence where computers learn from data to make predictions or decisions without being explicitly programmed for every task. The certification covers 4 main topics, which is data engineering, which will be the preparing and processing of data for machine learning. Then the model development, which will be designing and creating machine learning models. Then we have the training, which shows teaching the model to make accurate predictions. And then we have deployment, which is making the model available for users and applications. And finally, we'll also be covering MLOps, which will be managing models in production environments, similar to how DevOps manages software applications. So to give you an example, imagine that you're working for an online retailer and you need to predict which products a customer might be interested in. This certification equips you with the skills to build a recommendation engine using Google's cloud services. Now let's talk about the exam itself. The exam features multiple choice questions that test your ability to solve real-world machine learning challenges using GPC's capabilities. Multiple choice questions are questions where you'll select the correct answer from several options which are provided to you. Managed by Google Cloud, this certification stays up to date with industry trends, making it a valuable benchmark for cloud-based ML expertise. In short, achieving this certification demonstrates your proficiency in working with data, which is handling large data sets, training models, using advanced algorithms to create accurate models, using tools like Vertex AI, TensorFlow, and BigQuery. And we'll also give you an explanation of all of these tools right here. Vertex AI is Google's unified platform for building and deploying the machine learning models. TensorFlow is an open source machine learning framework used for numerical computation and large-scale machine learning. And BigQuery is a fully managed serverless data warehouse for scalable data analysis. Don't worry, all of these terms will be covered in detail in our whole program, and we'll give you an easy explanation for all of these services when you'll be working with them hands-on. In short, all of these services will help you in many ways. So suppose you're analyzing some customer data to find patterns in purchasing behavior. With these tools, you can process vast amounts of data and build models that provide you actionable insights. I'll explain you why this certification matters even more. By earning these certifications, you're affirming your ability to effectively design, implement, deploy, and maintain machine learning solutions using the GCP services. In today's whole data-driven world, businesses rely on machine learning to gain a competitive edge. Your certification signals to employers that you have the expertise to contribute significantly to their ML initiatives. You can think of this whole certification like earning a black belt in machine learning on Google Cloud. It's a clear indication of your skill level. Now we'll show you all of the exam sections and their weightages. So we have the first section, which is architecting low-code ML solutions, which will be 12%. Then the second section talks about collaborating within across teams to manage data and models, which will be 16%. Then the third section will be about scaling prototypes in the machine learning models, which will be the weightage of 18%. And the fourth section will be serving and scaling the models, which will be 19% of the whole certification. And the fifth section is about automating and orchestrating the ML pipelines, which will be of 21%, which will be the highest out of all of the sections. And the last section is just monitoring the ML solutions, which is 14%. So these percentages indicate the weight of each section in the exam. Focusing on sections with higher percentages can help you maximize your score. Let's talk about this image in detail. This image shows three main ways to do machine learning based on how much it is needed. First one is no code AutoML. You don't need to write any code in this method. It's simple and quick, and it's especially good for beginners. Then we have the low code, which is BigQuery machine learning. In this case, you just have to write a little code, and it's easier for people who know some tech but don't want to get into coding a lot. Then we have the custom machine learning. And this is for advanced users who want full control and can code. It includes preparing and labeling data, training and testing the model, making predictions and checking results, and keeping track of data and models. Finally, monitoring models and making them fair and clear. Pipelines help organize all these steps so everything runs smoothly from start to finish. So in short, this image shows options for building ML models from easy, which is no code, to advanced, which is custom coding. So now we'll discuss the difference between AI, ML, and Gen AI, as you can see in this image right here. So let's discuss this image. This image shows how different types of AI are connected. So first we have artificial intelligence. This is the biggest category. It means making computers act smart like humans. That's what artificial intelligence is in a nutshell. Then we have machine learning, which is a part of AI. It's when computers learn from data to do tasks without being told exactly how. Then we have deep learning. This is a part of ML. It uses very complex programs, which is called neural networks, to handle more advanced tasks like understanding speech or recognizing images. And then we have generative AI, which is a type of deep learning. It uses big data to create new content, like writing text or making images. So you can think of all of these layers as AI is the biggest layer, then ML is inside it, and then DL is inside ML, and then just generative AI is the smallest and the most specific part inside DL. So as you can see this whole image right here, generative AI being a subset of deep learning being a subset of machine learning, and machine learning in turn being a whole subset of AI. So this was the whole image in detail. Now we'll continue on with the rest of the document. So we'll discuss the first section, in which we'll explore how to build machine learning solutions using minimal coding using Google's powerful tools. So first we'll check the agent builder right here. So let me zoom on to this image right here. This image explains on how you can create an AI agent with different levels of coding skills, from no coding at all to full coding. Here's a simpler breakdown. We have the agent builder right here, which helps you build AI agents, whether you can code a lot, a little, or not at all. Then we have all of the tools. So first we have the orchestrate, which are tools to help you plan and organize what AI does, like using LangChain. Then we have ground and augment. This connects the AI to the internet or your own data to give it more information. And then we have take action, which lets the AI perform tasks by adding features called extensions. And then we have the primitives. These are basic helper tools, like ones that can read documents. And then we have the whole model builder and the model garden, as you can see right here. These are extra places to find and create models that your AI agent can use. The whole idea is to make building AI agents easy, even when you don't know how to code much. This is the whole specialty of agent builder and machine learning in general. So now let's discuss each of the modules in detail. So first we have developing machine learning models using BigQuery ML. BigQuery machine learning allows you to create and run machine learning models using the SQL queries. This is great because you don't need to be an expert in programming, like Python or Java, to build models. So in this case, you just have to choose the right model for the problem that you have. Like, for example, linear or binary classification. You can use this when you want to categorize data into two groups. For example, predicting whether an email is spam or not. Then we have regression. So you can use this when you're predicting a continuous value, like a price of a house based on its features. Then we have time series. This is ideal for forecasting future data points like stock prices or sales numbers over time. Then we have the using BigQuery ML for feature selection to improve model performance. It's about choosing the most relevant variables or features that influence your model's predictions. This improves model performance by eliminating irrelevant data. So I'll give you a real-life example for BigQuery ML. Suppose you're trying to predict housing prices. Features like the number of bedrooms, location, and square footage are relevant, while the color of the front door might not be. After training your model, you can use it to make predictions directly in BigQuery, for instance, predicting future sales based on past data. The next subpoint which we have is building AI solution with ML APIs. Google provides you pre-built machine learning APIs that allows you to build advanced capabilities to your application without building models from scratch. So Google's ML APIs include Cloud Vision API, which analyzes images to detect objects, faces, and text within images. Then we have the Natural Language API, which understands and analyzes text for sentiment, entities, and syntax. Then we have the speech-to-text API or the text-to-speech API. This converts spoken language into text and vice versa. Then we have the translation API, which translates text from one language to another. We also have industry-specific APIs like Document AI or Retail API. Document AI is for processing and extracting information from documents like invoices or forms, and Retail API enhances retail experiences with personalized product recommendations. So a whole example for this is, imagine if you're building a mobile app that translates street signs for travelers. You can use Cloud Vision API to read text from images and Translation API to translate it to the user's language. These are the use cases you can have with the APIs we mentioned over here. Now we have training models with AutoML. AutoML allows you to train custom machine learning models with minimal coding by automating the complex steps involved. So which is preparing data for AutoML. You can select features, choose the relevant data points that influence your outcome. You can label the data. You can assign it correct labels to your data. For example, labeling images of cats and dogs accurately. You can use tabular workflows for structured data like spreadsheets. And you can also use training models for various types of data. So AutoML supports text, images, and videos, making it versatile for different applications. A real-life example of this could be that if you have a collection of customer reviews, you can use AutoML natural language to train a sentiment analysis model that classifies reviews as positive, negative, or neutral. And at the end, we have configure and troubleshoot the trained models. AutoML provides tools to fine-tune your model's performance and resolve issues like overfitting or underfitting. Since we discussed the first section, now we'll discuss the second section, which is collaborating within and across teams to manage data and models. So first, let's discuss this image right here. This image shows on how we can clean and prepare data before using it. It is like organizing and simplifying messy information so that you can work with it better. It has three main steps, which is data cleaning, data transformation, and data reduction. I'll explain each of the steps in detail. Cleaning the data basically means fixing the missing parts. You skip the incomplete parts or fill them up with guesses or averages. You fix noisy or messy data, and then you can group similar data together and use patterns to predict the missing parts or organize similar items. Then we have changing the whole data. Making the data to fit into a standard size or scale. You can choose only important pieces of information in this type of reprocessing. Choosing only the relevant important pieces of information, turning long lists of numbers into simpler categories, and then grouping details into broader categories to make them easier to understand. And the final preprocessing step is data reduction. You can summarize big sets of data to make it smaller and easier to handle, picking out the only important bits and getting rid of the extra information. You can also shrink the number of details while keeping out the main parts. Overall, these steps make messy, complicated data easier to understand and use. So in this section, collaborating and effective data management are really crucial in machine learning projects. So let's begin with the first subsection, which is 2.1, exploring and pre-processing the data. So in this case, we'll organize various types of data. We'll ensure your data is well organized, whether it's text, image, or numeric data. We'll be using tools like the Vertex AI for managing data sets. Vertex AI provides a unified platform for managing data, as we discussed earlier. And then we'll also pre-process data using Dataflow, TFX, or BigQuery. These are the services that you can find in Google Cloud. So let's discuss BigQuery again. In BigQuery, data processing involves cleaning and transforming data to make it more suitable for modeling. So it has the Dataflow, which handles data processing pipelines. It has TFX, which is the TensorFlow extended. It manages end-to-end machine learning pipelines. And it also has creating features with the Vertex AI feature store. This is a centralized repository that lets you store and serve machine learning features for both training and serving. This also includes being mindful of privacy. So we have the PII or the PHI, which stands for personalized identifiable information like names or social security numbers, and the PHI, which stands for protected health information related to medical records. Always ensure compliance with data protection regulations like GDPR or HIPAA. The second subsection we have is the model prototyping using Jupyter notebooks. So in this case, we'll be selecting the right Jupyter environment. Like the Vertex AI Workbench provides managed notebooks with built-in security and scalability. Then we have the data proc, which is good for big data processing with Spark and Hadoop. The next subsection will be tracking and running the ML experiments. We'll be choosing the right environment for experimentation, and we'll also be using tools like TensorBoard for monitoring model performance. So in this case, if you're learning a model to recognize handwriting digits, TensorBoard can help you see the model in improving over time or if it's stuck. Now let's discuss the next section, which will be scaling prototypes in the machine learning models. This section focuses on taking your prototype models and building them for production. So in this, the first subsection is building models. We'll be picking the right ML framework and model architecture. We'll choose a framework that suits your project needs and team expertise. And after that, we'll be training the models. We'll be organizing the training data using the cloud storage or BigQuery. And the third subsection will be choosing the appropriate hardware for training. We'll be selecting the right compute resources, like the correct CPUs for good and simple tasks or small data sets, and GPUs to accelerate computations for deep learning. And then we also have TPUs, which are for tensor processing units designed by Google for high performance machine learning tasks. After training your model, you'll need to deploy it so that it can make predictions in the real world applications. So the first section is serving models. We'll be using batch or online methods for prediction. Batch predictions is for processing large amounts of data at once, ideal for tasks like end of day financial reports, and online predictions, which are real-time predictions for immediate results like fraud detection during a transaction. So in this case, we'll be using the same tools like Vertex AI, Dataflow, and PyTorch. In the second subsection, we have scaling online model serving. And this will be using the Vertex AI feature stores and setting up endpoints, which are the public endpoints and the private endpoints. And then we'll also be using the load balancer in this section. And in the fifth section, we'll be automating and orchestrating the machine learning pipelines. This section is about automating your machine learning workflows to make them more efficient and scalable. We'll begin with the first subsection, which is developing end-to-end machine learning pipelines. In this, we'll be validating data and models to ensure quality. In this case, it will be data validation and model validation. And on the basis of cloud, MLflow is a platform for managing the machine learning lifecycle. These tools help you manage complex workflows and multiple steps. A real-life example of this could be automating the retraining of a model where the new data is available, ensuring your model stays up to date. The next subsection we have is automating model retraining. In this case, we'll just be setting up a policy for when to retrain the models. It could be time-based or event-based, or it could also be done using the CI/CD tools, which means continuous integration and continuous deployment. These tools are for automating the deployments. Then in the next subsection, we'll be tracking and auditing the metadata. This simply means just keeping track of the model versions and datasets using Vertex AI experiments. This helps in reproducing results and understanding the evolution of models. A real-life example of this could be in a regulated industry like finance or healthcare, being able to trace back how a model was developed is essential for compliance. Now we have the sixth section, which is monitoring the ML solutions. This ensures that your machine learning models continue to perform well over time. So in this, the first subsection we have is identifying risks to the ML solutions. In this, we will learn on how we can build and secure the machine learning systems to protect against the vulnerabilities. We'll implement security measures to protect data and models from unauthorized access, following the Google's responsible AI practices to avoid bias in models. We'll talk about bias and fairness in detail. A real-life example of this could be a hiring algorithm should not favor candidates based on gender or ethnicity. The next subsection we have is about monitoring, testing, and troubleshooting the ML solutions. We'll be setting up continuous monitoring with tools like Vertex AI Monitoring, automatically tracking models' performance metrics. So in this case, we'll ensure that the model is still meeting performance expectations. In a real-life example of this could be if a credit scoring model starts to decline in accuracy, you need to identify the cause and retrain it to adjust the model. And with that, we have covered all of the 6 sections of the Google Cloud Professional Machine Learning Engineer Certification exam. By understanding these areas and how they apply to real-world scenarios, you're well on your way to becoming a certified cloud professional. Now we have the practice tests. Now that we have covered all of the key sections of the exam, it's time to focus on preparing effectively. One of the best ways for this is by taking the practice sets. So you could visit this link right here. We have already discussed this link previously, like I showed you on how you can check out all of the sets over here. So you can also check this out by going to the main job-oriented program and clicking on the quick links. And from the quick links, you can find out the certification exam question and answers. And by clicking over here, you can find out the same page. You can find out the same web page where it gives you all of the certification exam question and answers. So you can go back to the document. We also have the sample exam questions from Google. So you can head over to this link and you can enter all of this details. This is a form by Google. So you can answer all of this. And these are sample questions. You can register like using your first name, last name, and an email. And you can follow along the next steps. So practice tests are important because it helps you familiarize yourself with the whole exam format. You can understand how questions are structured and what types of questions to expect. You can identify the knowledge gaps and pinpoint areas where you need to focus more study time. This also helps you build confidence, like it can reduce exam anxiety by stimulating the test environment. Now in the next section, we'll discuss the frequently asked questions. First, we'll discuss the non-technical ones and then we'll discuss the technical ones. So the first question in short is the Google Cloud certification worth it? So the answer is the value of the Google Cloud certification depends largely on your career aspirations and how you intend to use machine learning and artificial intelligence in your role. If you're working with the Google Cloud platform or plan to, this certification is a great asset. The target audience is machine learning engineers and data scientists. This certification is specifically designed for professionals already working in machine learning or data science roles, with an emphasis on those familiar with Google Cloud's AI services, including Vertex AI and BigQuery ML. The benefits of the certification is industry recognition. Google Cloud Platform is one of the leaders in cloud technology, and earning a machine learning certificate from Google Cloud provides credibility and recognition within the AI/ML industry. We'll also discuss the use cases. For engineers and data scientists, this certification provides an in-depth, hands-on approach to Google Cloud tools like Vertex AI, BigQuery ML, and AutoML to build, train, and deploy machine learning models. We'll also talk about the limitations. This certification assumes a strong foundation in cloud computing and machine learning, for which we already give you a free cloud course. And if you're new to either one of them, it's recommended to start a fundamental certification like the Google Cloud Associate Engineer before pursuing this one. And the certification is mostly just for the Google Cloud Platform. This focuses on the Google Cloud's ecosystem. While the concepts can be applied across platforms, the practical knowledge is specific to the Google Cloud Platform tools. So in conclusion, the Google Cloud Certified Professional Machine Learning Engineer certification is a strong credential for professionals looking to deepen their expertise in machine learning and AI, particularly in the Google Cloud environment. Now let's check out the next question, which is what is the passing score for the Google Cloud Professional Machine Learning exam? The exam is scored on a scale of 100 to 1000 with a minimum passing score of 700. The score reflects on your overall performance across the various exam sections, and a score of 700 or higher is required to pass the certification exam. The next question is how much do AI/ML certified people make? So you can check out this link right here by Amazon. So you can read this whole blog right here in which they explain in detail like how much do AI/ML professionals usually earn. We have shown a couple of screenshots. So this image highlights a significant challenge in the job market related to AI talent. It states that 73% of employers view hiring people with AI skills as a top priority because 3 out of 4 of these employees struggle to find the qualified AI talent they need. It emphasizes that while AI is becoming crucial for transforming how businesses operate, there is a gap between the demand for AI professionals and availability of skilled workers. This insight comes with a survey conducted by the Access Partnership and Amazon Web Services involving thousands of employees and organizations across the US. This image explains that learning AI skills can help you earn more money and grow your career faster. It shows that organizations are willing to pay 47% more for IT workers who have an AI expertise. This is because employers believe that people with AI skills can improve their company's efficiency, productivity, and decision making. So having AI skills makes you more valuable and leads to higher pay. Let's look at this image in detail. This image provides you an overview of expected salaries for machine learning and AI engineers in different regions. It highlights that in the United States, the average salary of a machine learning engineer is shown to be around $236,000 per year, with the salary ranges from about $90,000 to $300,000. In Canada, the average annual salary for a machine learning engineer is approximately $140,000, with a typical pay varying between $76,000 and $184,000. The chart and listings also indicate salary variations depending on experience, company, and location. For example, some of the top companies offer competitive salaries for machine learning roles. Overall, this image illustrates the fact that machine learning and AI professionals can expect high salaries without potential earnings increasing with experience and expertise. So this image is a screenshot from LinkedIn showing job listings for roles related to generative AI in the United States. It highlights an example position at Amazon Web Services for a generative AI strategist at their Generative AI Innovation Center. The job offers a salary range between $138,000 to $239,000 per year, and this is a full-time position. Other job postings from companies like Nvidia and Visa are also listed, showing that there are multiple opportunities in the generative AI field with potentially high salaries and various job roles available. This emphasizes the demand for skilled professionals in generative AI and related technologies. Now let's discuss the next question, which is what does the Google Cloud Certified Professional Machine Learning Engineer certification entail? So this certification validates your ability to design, deploy, and maintain machine learning models using the Google Cloud Platform services. It covers a range of topics including data preparation, model training and tuning, hyperparameter optimization, deployment, scaling, and monitoring the GCP tools like Vertex AI, BigQuery ML, AutoML, and more. Now we will discuss who should take the Google Cloud Certified Professional Machine Learning Engineer exam. This certification is ideal for machine learning engineers, data scientists, and software developers who have at least 1 year of experience in designing and implementing machine learning models on Google Cloud. It is also suitable for professionals with backgrounds in data engineering or DevOps who want to specialize in AI and ML deployments using Google Cloud Platform using the GCP's advanced toolsets. The next question is, do you need coding skills for the certification? Yes, coding skills are essential for this certification. You'll need proficiency in programming languages like Python and a basic familiarity with the machine learning frameworks like TensorFlow and PyTorch. Additionally, the exam covers aspects of data preprocessing, model training, and hyperparameter tuning, which requires coding knowledge for tasks like feature engineering and using GCP's tools. The next question is, how will the certification help advance my career? Earning the Google Cloud Professional Machine Learning Engineer certification showcases your expertise in building and deploying scalable machine learning models using Google Cloud's AI tools. With AI and machine learning rapidly expanding across industries, this certification can help you secure advanced roles in AI and ML and data science. So certified professionals are high in demand, often securing positions with more responsibility and competitive salaries. So the next question is, what certification should I pursue after obtaining the Google Cloud Professional Machine Learning certification? After this certification, you may want to explore further credentials. Depending on your career goals, consider Certified Professional Data Engineer if you want to specialize in managing data pipelines and preparing data for AI solutions. Then you could also go for the Google Cloud Certified Professional DevOps Engineer for those interested in automating machine learning workflows and continuous integration processes. You can also go for the advanced Google Cloud AI certifications if available for professionals who want to dive deeper into generative AI, MLOps, or advanced AI architectures. The next question is, what are the prerequisites for the Google Cloud certification program? While there are no official prerequisites, it's highly recommended that you have at least 1 year hands-on experience of using the Google Cloud services for machine learning and also a solid understanding of machine learning concepts and algorithms. You also need experience with programming languages like Python and a basic familiarity with the GCP tools such as Vertex AI, BigQuery ML, and Dataflow. Now we'll discuss the technical questions and answers. The first one being, what are the key concepts of ML development lifecycle? So the machine learning development lifecycle is a series of steps that guide creation of machine learning models from start to finish. So here is a breakdown of each section. So first we have the data collection, which is gathering raw data from various sources relevant to the problem that you're trying to solve. Then we have the exploratory data analysis, which is also called the EDA for short. This is analyzing the collected data to understand its characteristics, spot patterns, and detecting anomalies. Then we have the data preprocessing, which is cleaning and transforming data to make it more suitable for modeling. This includes handling missing values, correcting errors, and normalizing data. And then we also have feature engineering, which is creating new input features and modifying existing ones to improve the model's performance. Then we also have model training, which is feeding the preprocessed data into a machine learning algorithm to learn patterns and make predictions. Then we have hyperparameter tuning. This is adjusting the settings of the learning model to optimize the model performances. Then we have evaluation. Evaluation is accessing the model's performance using metrics like accuracy, precision, recall, or the mean squared error. And then we have deployment, which is integrating the trained model into a production environment where it could make predictions on new data. And finally, we have monitoring, which is just tracking the model's performance over time to ensure that it remains effective and making updates as needed. The next question is, what is generative AI and how it could be used? Generative AI refers to a class of artificial intelligent models that can generate new content such as text, images, music, or even videos. This is similar to the data that they were trained on. The way it works is that generative AI models learn the underlying patterns and structures of the training data. They can create new data instances that resemble the training data but are not duplicates. There are many common applications of it, which is the image generation, chatbots and conversational AI, language translation, content creation, and recommendation engines. It is important because generative AI expands the possibilities of what machines can create, opening up new avenues for innovation in various industries. The next question is, how can you secure AI systems on the Google Cloud Platform? So securing AI systems on Google Cloud Platform involves several best practices to protect data models and resources. The first one is identity and access management. IAM in short allows you to control who has access to your resources and what they could do with it. The way they work is they grant least privileges by assigning only necessary permissions to users. So for example, a data scientist might have permission to read data and train the models, but not to deploy them to production. It can also do it by data encryption, network security, and securing the service accounts. So this is important because securing AI system protects sensitive data and manages the user trust. It ensures compliance with the regulations as well. The next question is, what is prompt engineering and why is it important? Prompt engineering involves crafting effective input prompts to guide the outputs of AI models, especially large language models like the GPT-3. It is important because it improves the response quality, it avoids misinterpretations, it helps mitigate risks, and it ensures that the AI doesn't generate inappropriate or harmful content. And the last question we have is, what is the difference between supervised and unsupervised learning? This is one of the key questions in the machine learning field. In short, supervised and unsupervised learning are two fundamental approaches in machine learning. They are differed mainly on how they use labeled data. In supervised learning, the model is trained on a dataset that includes both input features and the known output labels. Whereas in unsupervised learning, the model is trained on data with explicit labels, aiming to find the hidden patterns or structures. The key differences being supervised learning requires labeled data and unsupervised learning does not. So this means choosing between supervised and unsupervised learning depends on the problem you're trying to solve and the type of data you have. So they both are good in their own way. With the frequently asked questions and the technical questions done, we're going to take a deep dive into the modules. So you'll study what the Google Cloud Professional Machine Learning Engineer certification exactly is. We'll break down each module of it, explain the key concepts in simple terms, and highlighting the hands-on lab that will solidify your understanding. So first you can click on this link right here, which will give you a step-by-step guide on how many hands-on lab that you will have to do for this certification. So we'll just wait for the site to load up. So you can go through this whole blog right here and I'll give you a step-by-step guide on which all hands-on lab that you have to perform, giving you a brief description of what you are exactly going to do in that lab. So I would recommend you checking out this blog to get a brief overview of what all the labs will look like. Once you're done going through that blog, you can continue on these steps where we'll cover all of the modules that you're going to work with. So first we have the strong data basics. We'll give you an introduction to data. We'll discuss what data is and the different types of data like structured, which could be tables in a database, unstructured, which should just be plain texts, images, and videos, and semi-structured, which are like JSON files. We'll also discuss the data lifecycle. We'll understand the different stages the data goes through from creation and storage to processing, analysis, and eventually archiving or deletion. Then we'll also discuss the data structures. We'll learn about the different ways you can organize and store your data effectively in arrays, lists, dictionaries, and data frames. So this model is important because it gives you a strong grasp of data basics. It ensures that you can effectively handle and prepare data for machine learning models. The second module we have is about AI/ML introduction. Here we'll delve into the exciting world of artificial intelligence and machine learning. We'll give you the difference between AI and ML. We'll explore supervised, unsupervised, and even reinforcement learning. This is important because understanding these concepts is crucial as they form the foundation upon which advanced topics are built. The third module is about machine learning packages. So we'll explore the essential Python libraries that make up data manipulation and machine learning tasks more manageable. We'll talk about the different types of packages that you will have to install, like the NumPy package, Pandas, and even Matplotlib, and even scikit-learn. These are machine learning libraries featuring various algorithms like classification, regression, and clustering. You can check out all of the hands-on lab for this module in the blog right here. We have mentioned all of it in step-by-step detail. So it is important because these tools are the bread and butter for any ML engineer, enabling efficient data handling and model development. Now we'll discuss the fourth module. This module focuses on preparing your data and choosing the right algorithms. So the topics covered in this are mostly data preprocessing and feature engineering. And these are the hands-on lab for this specific module. It is important because mastering these concepts enhances the model accuracy and efficiency. The next module is landing zone for Google Cloud. We'll learn on how you can set up a scalable and secure environment in Google Cloud for your ML projects. The topics covered in this are elements of the landing zones in Google Cloud. We'll give you the best practices and also a lab for the landing zones. It is important because a well-structured cloud environment is essential for efficient resource management and security compliance. The next model is about organizing data with Google Cloud. So this model focuses on managing and storing data using the Google Cloud services. We're going to cover the different types of data management solutions and the object storage and databases in the Google Cloud platform. It is important because proper data organization ensures smooth data retrieval and management, which is crucial for machine learning workflows. In the seventh model, we'll be talking about the service BigQuery. This is Google's powerful data warehouse solution. It is important because BigQuery allows you to handle big data efficiently, making it essential for large-scale ML projects. The next model is about innovation with the Google Cloud Artificial Intelligence. We'll explore Google's AI and ML services to build intelligent applications. The topics under this is AI and ML under Google Cloud. It is important because all of the labs mentioned over here provide practical experience with AI services, which is crucial for building real-world applications. In the next module, we'll learn about the Vertex AI and how it works. We'll learn on how to leverage pre-built models to accelerate the ML projects. It's important because using pre-built models can save time and resources, allowing you to focus on customizing solutions. And the 10th model will be about prototypes into the ML models. We'll show you to transition from prototypes to production-ready models. We'll understand how to select the right tools and architectures, ensuring that your model is effective and scalable. In the 11th model, we'll show you on how you can start scaling the ML models. We'll focus on deploying models that can handle production workloads. The topics in this will be the Vertex AI feature store and endpoints. It is important because scaling models is essential to meet the demands of the real-world applications with many users. And the last module will be for MLOps and the managed services. We learn on how we can monitor and maintain your models after deployment. The topics in this is establishing the continuous evaluation metric and setting up the monitor model performance over time and detecting issues early on. It is important because MLOps practices ensures that your models remain effective and reliable throughout the whole life cycle. With this, we have discussed all of the 12 modules for this certification. And now to further enhance your learning experience, you can check out these relevant references. So first, we already discussed this blog link right here, which gives you a step-by-step guide on the hands-on lab, which you have to do, as we already discussed it. Let me just close all of the tabs that we opened. And you can also check out this blog, which will give you more details about the certification that you're going to work with. You can find out what the certification is about, why you should pursue it, and you can refer to this whole detailed blog, which will give you a step-by-step instruction on what you can do. After that, these are the references from Google Cloud. If you click on this link, it will take where you could register for the certification and you can schedule an exam. You can click on this and you can register for your exam. And the other link, which is the exam guide by Google. So you can download this PDF file and use for your own reference. And that's everything you need to know about the Google Cloud Professional Machine Learning Engineer certification. I hope this video has provided you with a comprehensive roadmap to prepare for the exam and a deeper understanding of what's involved. Remember, practice makes perfect. Make sure to do all of the hands-on lab and thoroughly go through the practice tests. Stay updated. Always refer to the latest documentation and resources as technologies and exam patterns don't really change. And please don't hesitate to ask questions. If you have any doubts or you need further clarification, feel free to leave a comment below and we'll be ready to help you. I'm confident that with the right preparation and dedication, you'll soon be a Google Cloud Professional Machine Learning Engineer. Once you are certified, please share your success story with us. It not only inspires others, but also strengthens our learning community. Thank you for watching this video, and if you found this video helpful, you can give it a thumbs up. You can subscribe to our YouTube channel for more insights on cloud certifications and machine learning, and you can share it with anyone who might find it useful. And best of luck for your certification journey.